Hello everyone. So let us move to another last part of this unit, namely alkaline earth metals. Before going to the session, I would like to tell one thing that I am more preferable with this type of presentation rather than taking on a board and projecting to you. I would like to use this PPT presentation, record it, and post in the form of post through YouTube. The advantage is that you can see any number of times, and also you can also this is coupled with the internal assessment. That is one thing. The another advantage is this: I can use different images. I can use different images, video file, text file, diagrammatic formation. So whatever that comes in digital form, I can use this. In the case of teaching through Blackboard, these things are not at all possible. And one disadvantage I feel is the interaction with you is not it's not happening here. But anyway, whatever you have doubt, you can clarify it always through WhatsApp whenever you need. Okay, so with these with this, I'll go for the presentation. Always, chemistry is not separable from biology. If you take our own body, our own human body composition, there are plenty of chemicals. But since we are in the part of alkali and alkaline metals, I'm not going beyond those two groups. So we have here on the left part hydrogen. So basically, our body is composed of water, out of which hydrogen is there. Hydrogen is one of the elements in water, and we have calcium. So calcium is present in bones and tooths. We have on the right hand side you can see potassium and nitrogen. So both are useful for keeping blood volume level. So whenever we are in dehydration, that time doctors advise to give oral hydration solution, which consists of mostly potassium and sodium ions. And lime consists of mostly potassium and sodium ions. That's why we drink lime also. So another major important function of this sodium and potassium ions are in communication. Communication between one neuron to another neuron. Suppose if you touch a fire, so we feel the heat and immediately we feel the heat and it is communicated to our brain. All these things are happen through the neurons, and neurons communicates using the sodium and potassium ions, which is present in our body. And magnesium we have this is present in many enzymatic reactions in our body. So these are the biological applications of both I am telling alkali and alkaline earth metals. So let us move into the today's session. So it is alkaline earth metals, and we go like this. So first is the metal, then the property, which is subdivided into two sections: physical and chemical, and finally with uses we finish this part. So last class we have seen alkali metals, and this class we are seeing alkaline earth metals, and again there are 6 elements which starts from beryllium, magnesium, calcium, strontium, barium and radium. They are as similar as to alkali metals, and it is less reactive than alkali metals. So alkali metals, they are more reactive, that sodium, potassium, rubidium and all more reactive than this group of metals. Okay. And in the just you can see in the periodic table the first part, with the exception of hydrogen, the first group we say it's alkali, the second group alkaline earth metals. So we know the name how it is coming, alkali metals. So upon dissolving in water, it forms base. Therefore, the base we call alkali, hence the names are alkali metals. And what about alkaline earth? Even these alkaline earth metals are also same as like alkali metal dissolves in water and forms base. That finds the name alkali, and these metals in the form of oxide, it is present in the earth, it is available to us, therefore alkaline earth metals. Okay, so now you see the periodic table, sorry, the table of column of all the elements with the atomic number, electronic structure and valence electron. So you see all the elements, it possesses a general electronic configuration of 2 electrons is the S substance. So everyone ends with S2 configuration, but different shell, second shell, third shell, fourth shell. Therefore, the general electronic configuration is this NS2, which means that there are 2 electrons in the outermost shell, which is available for bond formation. Therefore, the valency of these elements is 2. What is valency? So valency is nothing but so the tendency to form bond formation, or otherwise the another definition is the number of electrons present in the outermost shell. So if the number of electrons is 2, then it can form 2 bonds. Therefore the general electronic configuration is NS2 and also valency is 2. We move to physical properties. As like we start from clockwise lower left and we move to the right lower right. So as we have discussed in alkali metals, the atomic radii from the top to bottom, as we move down the group, it increases. As the atom increases, as the atomic size increases, the atomic radii also increases. So with the, as we move from top to bottom, one shell is getting increased, 2 to 3, 3 to 4, 4 to 5. One shell is getting increased, therefore the size increases and hence the radius increases. If the atomic radius also increases, then hence also ionic radius increases, both increases down the group. So then ionization potential. So as we have discussed earlier, do you remember what do you mean by ionization potential? It is the energy to remove the electron present in the outermost shell. Okay, an isolated element, an isolated atom. Okay, since there are 2 electrons, we do have 2 ionization potential in the outermost shell. So the first ionization potential and second ionization potential. So as we move down the group, as the shell is getting increased, as the distance from the nucleus and the outermost electron is getting increased, ionization potential decreases down the group. So then electropositivity. The alkaline earth metals show electropositive character which increases from beryllium to barium. So it's highly electropositive and low electron, which is the next subtopic. So it is highly electropositive and these are metals. Easily you can take out the electron out of it, the last electron. So electronegativity is the tendency to attract the electron pair towards itself, but these elements of low electronegative potential or no electro affinity. Okay, density of alkaline earth metals also decreases down the group, but it is in acyclic elements. Okay, these are the physical properties of the elements in this group. Now you could see the elements yourself, see the beryllium. So all are solids, all the elements are solids. So beryllium you can see, magnesium, and you know these magnesium are used in crackers. As you burn the crackers, you can see the colorful lights which comes out also are magnesium is one of the ingredient, and calcium. So you know calcium as calcium carbonate in chalk pieces. Chalk pieces possess chalk piece is calcium carbonate and calcium is there. Even pearl is also calcium carbonate, but with full crystalline structure. That is also calcium is there in pearl. Strontium, barium, and radium. These are the elements in its form. And let us move to the right part of it. So you have the elements and you have its own characteristics color. With that you can identify what the element is. Here we have given along with the alkali metals, alkali and alkaline earths. As you people know, you have done in our chemistry lab, even in 12th standard. Even we will be doing here also. So in inorganic analysis, inorganic qualitative analysis, where you find whether which is present, which elements is present, the acidic part and basic part. So you take some amount of water, dissolve in hydrochloric acid, and then you make a paste. That paste is inserted in the non-luminous part of the flame. By seeing the color of the flame, you will identify which element it is. Okay. So you have the alkali metals, lithium, sodium, and potassium. The first three, those colors are there: scarlet, yellow, and lilac. The rest you can see alkaline earth metal, calcium, strontium, and barium. If it is a brick red color, we have done this. It's calcium. If it is crimson, it will be a strontium. If it's apple green, then it is barium. So these are the characteristics. It's a signature. It's a signature of that particular element. So we move to the chemical properties. As like polymers, I'll start with the lower left and we will end with the lower right. And we will move in a clockwise manner. So with oxygen, the metal readily reacts with oxygen and forms metallic oxides. Some of the elements also form superoxide. The last part of the calcium, strontium, and barium reacts with oxygen and forms heavier metals. It forms superoxides or peroxides. Again, with the hydrogen, it reacts with hydrogen and form metallic hydride, as we have read in hydrates. So this forms metallic hydrides. So reacts with hydrogen, when heated with hydrogen, it forms metallic hydrides. And upon these hydrides, when you dissolve in water, it readily gives hydrogen. Okay, the third reaction is with nitrogen, that is the top left corner. So these metal reacts with nitrogen and forms metallic nitrides. Again, as like hydrides, these metallic nitrides reacts with water to give ammonia gas and metallic hydroxides. So we have given a general formula. You can write for individual elements, all those things. Suppose if I take the first one, you can see metal plus nitrogen gives metallic nitrogen. Let us take beryllium. Beryllium plus nitrogen gives beryllium nitride. If I take magnesium, magnesium plus nitrogen gives magnesium nitride. So it holds good for all those, all the metals. So therefore, a general chemical formula is given to this. The fourth one is with water. The metal reacts with water to form metallic hydroxide and hydrogen. So a small correction is that it's not immature, it is M. M reacts with hydrogen to give metallic hydroxides and hydrogen. And the last in the series is halogens. The metal readily reacts with halogen to give metallic hydrides. You can see there is a general formula for elements, that is metal. There is also general formula for halogen X. So where X is equal to fluorine, chlorine, bromine, and iodine. Any one of these. Suppose if the metal is beryllium and X is fluorine, so beryllium reacts with fluorine, gives beryllium fluorine. So like that we have to take one by one. Okay. So oxo acids. Again, in alkali metals, I have said oxo acids, but I have not dealt it in detail. Now I am doing that for alkali followed by alkaline earth metal. Both I am taking together. A good form I have found in topper.com. So I thank this the creator in this website topper.com. It was very wonderful for us. So I am presenting the same. We are going to that website to first I am taking it for alkali metals. So going to that particular website and we are seeing how oxyacids are there. That was very simple and they have given in a slide form, one by one slide. It goes from one to so, and also very small concept they have given in each slide. So it was easy to read. Hence instead of putting in the form of a PowerPoint slide, I am straightly going to that website itself. Okay. So here you are seeing the salts of alkali metals. Next, oxoacids are acids which contain oxygen. So if an acid contain oxygen, then we call it as oxoacid. So let us see the examples of those acids. Carbonic acid, H2CO3. This is what we drink in soda. Carbonic acid, sometimes we drink soda whenever indigestion takes place. So that is nothing but carbonic acid. So next is sulfuric acid, H2SO4 and nitric acid. These are oxoacids. Specifically, oxoacid is that combines one hydrogen atom attached to oxygen atom. Okay, let us see with a structure. So you see for this sulfuric acid, in H2SO4 you see the oxygen hydrogen is attached to oxygen, and also we have two oxo group, which therefore we call it as oxo acids. In sulfuric acid there are two oxo group and two OH groups. In OH group we have one hydrogen present in one OH group. Suppose if you take carbonic acid, there is one oxo group and two OH groups. And in nitric acid, again there are two, as like sulfuric acid, there are two oxo group and one OH group. But therefore, this we call an oxo group attached to acid, we call oxo acids. Now let us move to, there are hydrogen atoms here. These hydrogen atoms may be replaced by metals. And if you remove the hydrogen atom replaced by metals, then we call salt of oxoacids. So alkali metals can come in place of hydrogen. Therefore, this is a salt of oxoacids of alkali metals. Let us check. See, this is example sodium sulfate. Instead of two hydrogen, we have got two sodium. Therefore, it is sodium sulfate. So it's a salt of oxoacid. So the name comes from the other part. If it is carbonic acid, carbonate is the part. If it's sulfuric acid, sulfate is the part. If it's nitric, nitrate is the part. Instead of hydrogen, we will be having the metals. If you have the metal, say the name of the metal followed by the group of atoms. So in HNO3, if hydrogen is replaced by potassium, it is potassium nitrate. In sulfuric acid, if the hydrogen is replaced by potassium, it is potassium sulfate. If in carbonic acid, if hydrogen is replaced by potassium, it is potassium carbonate. So likewise, so you can see that the roots of the name: carbonic acid carbonate, sulfuric acid sulfate, nitric acid nitrate. So thus the salts of named of the metal of and the oxoacids. That's how it is being named. The alkali metals form salts with all the oxoacids. See, all the alkali metals, starting from lithium, it forms salts with oxoacids. So some properties they are given in that website. See, these oxoacids are ionic nature, and you know all ionic compounds is soluble in water. So like dissolves like. So water is polar, and we have a polar compound, ionic compound. Ionic compound dissolved in water, which is polar, like dissolves like. So these are thermally stable. Salts are thermally stable, carbonates and hydrogen carbonates. Also down the group, the stability increases. Starting from lithium, the stability increases. This is because as we go down the electropositive increases and the ionic bond becomes more stronger. As we move down the group, the electropositive character increases and the ionic bond is more stronger, and hence the stability increases. But only one lithium is a little bit out of this, and it is a little bit unstable. Suppose if we heat lithium, carbon dioxide and lithium oxide will be formed. So let us see and understand with the structure where you see the carbonate ion. In the case of lithium, this part alone, it goes as carbon dioxide, this part, CO2. Okay. So this part alone process, and this oxygen it joins with lithium and forms lithium oxide. So the remaining all other oxo acids are stable of carbonates. Lithium hydrogen is not stable. In fact, it's not even exists as solid. So one lithium metal is there, another will be a hydrogen, lithium hydrogen carbonate. LiHCO3 twice. Again, in this website they have given revision also. If people could go and read that revision also. The same thing they are given in a confined form. Okay. Okay, now let us move to the alkaline earth metals. Yes, I have clicked it. It will be moving. Little bit time it is taking. So now again we are going to the same website topper.com where we are going to see about alkaline earth metals, salts of oxo acids of alkaline earth metals. So it's one and the same. It's one and the same. Whatever we have seen for alkaline, the same holds good for oxo acids of alkaline earth metals. Okay, oxo acids of that we have seen previously how oxo acids are named, and these are the examples, and we are also giving one negative example. This is an acid hydrogen chloride where no oxygen is present, hence this is not oxo acids. And oxo acid is one which consists of oxygen, that's all. So this is a negative example. Again we have seen the same thing which we have seen for alkali metals. Now we move for alkaline earth metals. So calcium with carbonic acid, it forms calcium sulfate, which is oxo acid. The same thing as we have seen for alkali metals. Now it is for alkaline earth metals. Now these website is telling about few characteristics of alkaline earth metal carbonates. The carbonate salts of alkaline earth metals are insoluble in water. See, like magnesium carbonates, calcium carbonates, they are insoluble in water. Since it is insoluble in water, you can easily filter and separate. Whatever small the solubility decreases down the group. So that the solubility of carbonates in water, it decreases down the group, which means that beryllium carbonate is highly soluble and barium carbonate is less soluble. The carbonates of alkaline earth metal, how we can prepare? We can prepare by using another carbonate. Suppose you want to prepare magnesium carbonate. Suppose if you want to prepare magnesium carbonate, let us take nitrate. You have to dissolve the metal in nitrate. So magnesium you dissolve in nitrate, it becomes magnesium nitrate. To that magnesium nitrate, you add sodium carbonate solution. If you add that, the sodium in the carbonate is replaced by magnesium, and you will get magnesium carbonate solution. So how it is being prepared? So it's an exchange. So if you want to prepare magnesium carbonate, take magnesium nitrate. To the magnesium nitrate, you add sodium carbonate. Sodium is replaced by magnesium, and hence we will be getting magnesium carbonate. This is how the carbonates are prepared. Since we have said it is insoluble in water, you can easily filter and separate. So in this way, all the carbonates of alkaline metal are formed using sodium carbonate. So instead of ammonium carbonate also used in the place of sodium carbonate. The carbonates of alkaline metals, on heating it decomposes. On heating, carbonates give carbon dioxide and oxygen. Although the thermal stability of carbon increases down the group. So beryllium carbonate is increases down the group. The thermal stability increases. Beryllium carbonate is highly unstable and can be kept only in the carbon dioxide. Now let us move to sulfates. Unlike carbon sulfates are stable to heat, all the sulfates, so magnesium sulfate, calcium sulfate are stable to heat and they are readily soluble. So because of this we have discussed in case of alkaline earth metals where we have taken a particular example of lithium which reacts with water and that hydrogen energy is more enough to ionize lithium, so that we have seen only for the exception of that reducing property at the end of the session we have seen. So the solubility of sulfur decreases down the group. So nitrates of these metals are made by dissolving the carbonates in dilute nitric acids. So nitrates can be prepared by dissolving the carbonates in dilute nitric acid. So magnesium carbonate, if you dissolve in nitric acid, you will get magnesium. The metal is formed in hydrated form. So you could see that. So the intensity of hydration decreases down the group. Therefore, beryllium nitrate forms more hydration than the barium nitrates. So even that molecule takes water into it, whereas magnesium nitrate 6 molecules of water it will take, whereas barium nitrate does not take any molecule of water. It will be an anhydrous barium nitrate. As we have seen previously, this is because as moving down the group, the hydration energy decreases. Suppose this is for thermal stability. If you take nitrates and if you heat it, it gives nitrogen dioxide and oxygen. So this is a heat treatment. So with that it ends, and finally this is a revision. And you could also see from these websites and you can read it. And finally we are going for the uses. So beryllium, it is used in manufacturing alloys. It is also used in spring and magnesium. So magnesium, it's used in alloy with aluminum, zinc, and manganese. So in toothpaste, so everything. Calcium, it's present in our body. So calcium and barium used to remove the last traces of air in vacuum tube. Okay, so it removes the air in vacuum tubes, and radium is used to kill cancerous radiotherapy. A cancer patient can be treated with radium, so it kills specifically the colon cells in cancer cells. So this is the instrument which is used for radiotherapy for cancer patient. Okay. So thank you very much. Questions are there. You attend the questions there itself in our Moodle speech. So thank you very much. We'll meet in next class.